Engineering design process. The challenge. The challenge for this competition is to design a robot that is able to collect as many golf balls as possible and store them into the center structure. During this, the robot will face several challenges and obstacles. Here are some of the robot designs we picked out. And here are some of the human player designs we also picked out, that we also made. Here's our final human player device design. Some obstacles that we face. While working on a robot, we face obstacles such as having trouble with making the code for the autonomous challenge, struggling with the weight of the catapult, and finding the right speed to set the motor. The code for the autonomous challenge was difficult for us together. We faced a lot of trial and error, especially finding a way to put the code together and all its parts functioning well. We solved this problem by experimenting with the code and testing different code blocks. We struggled with the weight of the catapult since our original design was too heavy and slowed the catapult down, because we used metal parts. We solved this problem by using less metal pieces and using a plastic part of the wheel to be the part of the catapult that holds the ball. We also struggled with finding the right speed to set the robot's motors to, since the robot was moving really slow and the motor for the catapult wasn't moving fast enough to launch the ball far enough. We solved this problem by increasing the motor speed for the wheel and increasing the catapult's motor speed. Here's our final robot design. Theoretical information.
3 examples of how robots are used in sports are better stadium experiences, recording and replays, and sports retailing. For better stadium experiences, thanks to robots, fan will have a better experience with entrance wait times, and if the robot gets an AI, they could help guide you to your seats or to the stores you want to go. Recording and replays, drones can be used to record the right angles to display it on the huge screens around the stadium so viewers can see it. And for sports retailing, sales can be managed by robots and stock management can be covered by robots as well.
Theoretical information. Robots in real life. Areas robots are used in real life. Robots are used in real life in the industry and in the medical field / healthcare. The industry / industrial robots. Robots are being used for welding, painting, assembly, quality control, and inspection, machine tending, and manufacturing processes. Medical field / healthcare. Robots are being used in healthcare for things like surgery, cleaning / disinfection, therapy, and transportation. Some robots being used in healthcare are the Da Vinci surgical robot, the Xenix germ zapping robot, the PARO therapeutic robot, and CyberKnife robotic surgical system, and the Tug and autonomous mobile robot.
Theoretical information. Code explained. Lines 3 and 4 are the control parts of the code and are the base. The rest of the code is built on. Line 5 of the code makes the robot drive in reverse for 5 inches by making the motors connected to the wheels spin. Line 6 makes the robot wait 1 second before starting the next part of the code. Line 7 makes the claw close by spinning the motor connected to the claw forward by 90 degrees. Line 8 makes the robot drive forward 5 inches. Line 9 makes the robot turn left by 90 degrees.
Line 10 makes robot drive in reverse for 27 inches. Line 11 makes robot turn right by 90 degrees. Line 12 makes robot drive in reverse. Line 13 and 14 makes the robot continue driving in reverse until the color sensor detects red. Line 15 makes the robot stop driving. Line 16 makes the robot play the siren sound. Line 17 makes the robot wait 3 seconds before continuing following the code. Line 18 makes the robot drive forward for 6 inches. Line 19 makes the claw open by spinning its motor in reverse by 80 degrees.
Line 20 makes the robot drive forward for 6 inches. Separate control block line 22 through 28 to control the drive speed of the robot. Line 22 through 23, base and start of the code. Line 24 sets the robot drive velocity / speed to 30%. Line 26 to 27 represents the end of this part of the code.